Now transmission line is directly connected to alternator. For stability, angle at the sending end, that is delta, is same as angle at the alternator is same as sending end voltage. Reason, alternator point, sending end point both are having same angles, which indicates alternator is maintaining synchronicity with transmission lines. Automatically alternator is transferring maximum power to the load point or minimum power to the load point, maximum power. Reason, whenever both are maintaining synchronization, definitely we can transfer maximum power. That is first point. Second point is, alternator is a rotating device. Alternator is rotating device, therefore it is having speed. But transmission line will not rotate. Always it is fixed position. It is rotating device, it is fixed part. We have to tell both are in synchronism. How to tell both are in synchronism? By comparison of angles. Angle of sending end voltage, angle of alternator voltage, both are same. That means both are running in synchronism. Both are running in synchronism. Automatically maximum power is transferred to the load point. Therefore, the diagram is still simplified as alternator is connected directly to transmission line. Now concentrate. Alternator is connected directly to transmission line. Alternator will have two fluxes. One is stator flux, other is rotor flux. Angle between these two delta. Generated voltage of alternator is E. Angle between stator and rotor flux is delta. Sending end voltage Vs, current Is. Receiving end voltage Vr, current Ir. For stability, angle at the alternator, angle at the sending end will be same. Therefore, angle at this point, both are same. Angle at the load point is always 0. What the meaning of angle at the load point is 0 means, when compared to 0, this angle is leading, which means power is flowing from sending end to receiving end, but not from receiving end to sending end. Always remember, in gate level this type of questions are important from power system stability. Angle at this point is 0 means angle at this point is negative, which means always this angle is lagging or leading. Lagging with respect to this angle. Suppose this angle is 0, definitely sending end voltage is delta. Suppose sending end voltage angle is 0, this angle is minus delta. This angle is minus delta, which means load angle is lagging compared to source end. Reason, source is that sending end is supplying power to receiving end, but not receiving end supplying power to sending end. That is the reason why angle at this point, angle at this point both are same. Angle at the load point is 0, right? Now see, what is the topic right now we are discussing? Steady state performance of transmission lines. Any electrical equipment, what is EE? Any electrical equipment performance can be analyzed by two ways. One is by percentage efficiency, second one is by percentage regulation. Any electrical equipment performance can be analyzed by two ways. One is by percentage efficiency, second one is percentage regulation. We know any subject percentage efficiency is output power divided by input power into 100. Output power divided by input power into 100. First of all, transmission line is a three-phase system or single-phase system? Three-phase system. Transmission line is a three-phase system. Transmission line, if you are considering from here to here, one point to other point, where resistance will present, as an electrical engineer, always we have to tell, wherever current is flowing, their resistance will present. Therefore, resistance present throughout the line. According to right hand thumb rule, when current is flowing through the conductor, the four fingers are flux. The four fingers are flux. Therefore, when thumb is current direction, these four fingers are flux. The flux is linking the conductor, which is called as inductance. Inductance also present throughout the length. When current starts flowing through the conductor, some of the air molecules are ionized surrounding the conductor. The air molecules are ionized up to this point. The conductor is hypotential. Assumption the air molecules are ionized up to dotted lines. Therefore, across these two, a capacitance will develop throughout the length of the line. Capacitance, 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 capacitance. Therefore, tell me, throughout the length of the line, resistance is there. It is series element. Inductance is there, it is also series element. Capacitance is there, it is shunt element. Formation of capacitance is parallel series, parallel. Reason, conductivity present in the air around the conductor. Whereas conductivity is up to this point, it is low potential, whereas conductor is high potential. The potential difference coming between these 2 points will be represented by capacitance. Now tell me, total transmission line is forming naturally 3 elements. What are they? R, L, C. R and L is series elements or shunt element? Series element. Entire resistance I am considering at one point. This is called as lumped representation for simple analysis. Entire inductance I am considering at one point. This is inductance. Entire capacitance I am considering at one point. This is capacitance. Now tell me, R, L, C. All these 3 elements are separatedly physically. This representation is lumped representation. Here R, L, C all are combined in nature. This is distributed representation. This representation is distributed. Already network analysis you studied. Here R, L, C are separated. This representation is lumped representation. What is the advantage of lumped representation is we can apply KCL and KVL very easily. But for distributed elements we can't apply KCL and KVL. We can't apply KCL and KVL. That is the reason why for lumped representation RLC elements are separated. Now let me see transmission line. Already you understand now. Transmission lines are represented by how many elements? 3 elements. The element number 1 is R, element number 2 is L, element number 3 is C. Therefore, what are the elements? R, L, C. RLC elements. What is the efficiency formula? Output power by input power. What is output power? Sending end power or receiving end power? Receiving end power is output power. What is input power? Sending end power. Transmission line is a 3-phase system or single phase system? 3-phase system. 3-phase system. Loss is due to resistor or inductor or capacitor? Definitely resistor. Resistor is dissipating energy, whereas inductor and capacitor is saving energy. Therefore, here not saving, transmitting energy in transmission lines. Only resistor is dissipating energy. Therefore, loss is due to resistor. The loss due to resistor is I square R. Loss due to resistor is I square R. Loss due to resistor is I square R. 3 phases line. Each and every phase loss is I square. Total 3 phases, what is the loss? 3 into I square R. Total 3 phases, what is the power loss? 3 times of I square R. Now output power is receiving end power or sending end power? Receiving end. It is sending end power, it is receiving end power. Output power is receiving end, input power is sending end. Tell me receiving end power PR is equal to what I can write? Sending end power plus 3 into I square R. 3 into I square R. Now tell me percentage efficiency is equal to output power. What is output power, my dear? Receiving end power. Input power is sending end power, PS into 100. But we know that, I'm sorry, equation is written wrong manner. Sending end power PS is equal to receiving end power plus losses in the line. Because sending end is supplying power to receiving end. Therefore, sending end power PS is equal to what I can write? Receiving end power PR plus 3 into I square R. 3 into I square R. Now tell me, output power is PR, input power is PS, where PS is equal to PR plus 3 into I square R into 100. Right. Now, it is the percentage efficiency. I told that any electrical equipment performance can be analyzed by using percentage efficiency calculations and percentage regulation calculation. Percentage efficiency calculation going on right now. It is a percentage efficiency. Now percentage efficiency depends on which element? Among 3 elements, R is creating only loss. Therefore, percentage efficiency also depending only on resistance of the line, only on resistance of the line. We know that R is equal to, what is the formula? Rho L by A. Rho is resistivity, which is constant. Length of the line is in kilometers. Transmission line length is in kilometers. Area is in kilometer square. Which is dominating, kilometer square or kilometer? Kilometer square. Kilometer and square is cancel out, but still kilometer is dominant. That means area is dominating. Transmission line area of size of conductor is thicker. As area of cross section of the conductor is more, what about resistance will become less? When resistance become less, what about efficiency becomes more? Therefore, transmission lines are operating with high efficiency or low efficiency? High efficiency. That value is 95 to 98% in practical. 95 to 98%. Now, among three elements, which is creating loss? Resistance. Resistance of the long line is less. Reason? Area of the line is more. Area of cross section of conductor more. Automatically resistance less, efficiency more. Efficiency more means it is in between 95 to 98%. Right? It is the efficiency of transmission lines. Next, distribution lines also there. Distribution system is, see, losses are more in distribution or transmission. It is one of the interview question. Definitely answer is distribution system losses are more compared to transmission system. Reason, in distribution system there is a phase, there is a neutral in your street. How you are tapping power? By tapping to that energy meter to distribution lines, we are tapping power. These wires are called as service mains. What is the name of these wires? Service. To stop the aluminum disc. When disc is not rotating, the units also not increasing, but we are consuming power. It becoming commercial loss. It become what? Commercial loss. Next, another one of loss in distribution system is tapping up power from distribution lines without meter. Some of the villages, rural areas, the evening time the people are coming service mains to the distribution lines where they are consuming power without meter, but they are not paying any electricity bill. Therefore, it is called as improper loss. One is commercial loss, other is improper loss. Because of this, distribution system losses are more compared to transmission system. Now tell me, transmission system is operating at high efficiency or low efficiency? High efficiency, right? It is not have a problem of efficiency. One thing is over. What is the remaining thing? Now only I told any electrical equipment performance can be analyzed by two ways. One is percentage efficiency, second one is percentage regulation. Now coming to percentage regulation, percentage regulation of two types. Any electrical machine which producing output as mechanical, let us take motor. Motor is output is mechanical, input is electrical. In your home, motor is there. You are switching on the motor, that is electrical. What is it producing? Some water or some work. Therefore, output is mechanical. For that machines, we are calculating speed regulation. Any electrical equipment output is electrical. For that, we are calculating voltage regulation. Which regulation? Voltage regulation. The electrical machine which producing output as mechanical, for that we are calculating speed regulation. The electrical machine which producing output as electrical, for that we are calculating voltage regulation. Now, transmission line is electrical equipment or mechanical equipment? Electrical equipment. Therefore, transmission line performance is calculating by voltage regulation or speed regulation. Voltage regulation is represented by percentage of E is VR naught minus VR divided by VR into 100, where VR naught is no load receiving end voltage. No load receiving end voltage. Next, VR is full load receiving end voltage. See, what is percentage voltage regulation definition is, it is the change of voltage at the receiving end, because always we have to calculate voltage at the receiving end, means our side or generating plant, our side, because we are the output. It is the change of voltage at the receiving end from no load to full load while keeping sending end voltage constant and frequency of entire system also constant. What is the voltage regulation definition? It is the change of voltage at the receiving end from no load to full load, means without load, what is the voltage? By connecting entire load, what is the voltage? From no load to full load, how much change in voltage? When sending end voltage constant and frequency constant. If change of voltage from no load to full load is less, definitely there is a better voltage at the load point. Yes or no? All our electrical equipments are operating nicely. If change of voltage from no load to full load is large, the regulation also large. Change of voltage from no load to full load is large, difference also more, regulation also more. There is a poor voltage present at the load point. Change of voltage from no load to full load is becoming less, difference also less, regulation is less, there is a better voltage at the load point. There is a better voltage at the load point. What you understand from here is, transmission line performance is analyzed by two ways. One is by calculating percentage efficiency, second one is by calculating percentage voltage regulation. Which regulation? Voltage regulation. In order to determine, or in order to, we can say the transmission line performance is satisfactory. We can say the transmission line performance is satisfactory, provided that efficiency must be high value or low value? High value. And percentage of voltage regulation must be low value. When efficiency is high, regulation is low, then we can say performance of the transmission line is satisfactory. Reason, change of voltage from no load to full load is less, automatically there is a better voltage at the load point. For that, regulation must be low value. Efficiency is high value means losses are less. Anyhow, efficiency depends on which element? Resistance of the line. We know that resistance of the line is very less. Definitely there is a better voltage at the efficiency of the resistance of the line is less. There is a better efficiency at the load point. Yes or no? Because losses are less. Whereas voltage regulation depends on two elements. One is inductor and capacitor. One is inductor, other is capacitor. Efficiency depends on only one element. What is that? Resistance. Whereas regulation depends on two elements. We know that under no load condition, capacitance is dominating. Under no load condition, which is dominating? Capacitance is dominating. Under no load, C is dominant. When capacity is dominant, voltage at the receiving end is more than sending end or less than sending end? More than sending end. This effect is called as Ferrand effect. This effect is called as Ferrand effect. Next, under full load condition, which is dominant? Inductance dominant. Due to dominant of inductance, voltage at the receiving end is less than sending end voltage. Whenever voltage at the receiving end is less than sending end, definitely at the load point we have poor voltage. We have to improve the performance by increasing the voltage. See, under no load, capacitor dominating, by that voltage at the receiving end is more. Under full load, inductance dominating, therefore voltage at the receiving end less. Inductor is reducing voltage, capacitor is increasing voltage. One is increasing, other is reducing, therefore difference of voltage coming from no load to full load. That's why more regulation is coming. Which is creating problem? Regulation, because efficiency is not a problem. Reason, Resistance automatically less, efficiency always high. Therefore, there is no problem with efficiency. The problem with voltage regulation. Why the problem with voltage regulation is, under no load condition, capacitance definitely dominating, by that voltage increasing, due to inductance voltage reducing, the difference of voltage coming in between inductor and capacitor. That is the reason why regulation is creating a problem in transmission, but not efficiency. That is the reason why finally what we have to understand from this conclusion series, transmission line performance mainly is analyzed by voltage regulation value but not efficiency value. Reason, already efficiency value is higher, it is achieved. Which is not achieved? Low value of voltage regulation. That is the reason why transmission line performance is mainly concentrating on voltage regulation but not efficiency of the system. I hope it is clear my points. Total how many elements are there in transmission? 3 elements. One is R, second L, C. Which is deciding efficiency? Resistance. Which is deciding voltage regulation? Inductance, capacitance. Which is creating problem? Regulation problem. Which is not having problem? Efficiency. Therefore, finally, transmission line efficiency can be analyzed by using voltage regulation but not efficiency, right? Now, we understand very clearly that voltage regulation is a problem but not efficiency problem. Okay, let us concentrate right now. Input to the system is already we know, we are electrical network analysis itself we studied. Input to the system is sinusoidal waveform. Input to the system is sinusoidal waveform. It is called as one complete cycle. What the complete cycle is? Time taken to complete one full cycle is called as time period. This is one complete cycle. The wavelength of one complete cycle is lambda equal to C by F. Wavelength is lambda, which is equal to C by F, where C is velocity of the wave, which is equal to light velocity. What is light velocity, friends? 3 into 10 power 8 in meters per second, but transmission lines are kilometers now. 10 power 5 kilometer per second upon, what is the frequency of India? 50 Hertz. Instead of Hertz, I am writing cycles per second. Cycles per second. Second cancel out. Therefore, lambda becoming 3 into 10 power 5 by 50 is 6000 kilometer per cycle. 6000 kilometer per cycle. That means for one complete full waveform or complete cycle, the wave is traveling 6000 kilometers. It is completing 6000 kilometers for a full cycle, but physically the actual length of the transmission lines are not more than 250 kilometers. Wavelength is completed 6000 kilometers, one complete full cycle, but actual length of the transmission line is not more than 250 kilometers. Actual length of the transmission line is not more than 250, but wavelength is up to 6000 kilometers. Therefore, wavelength is more, actual length is less. Therefore, transmission lines are classified based on physical length of the line rather than wavelength. We know that transmission lines are different line models. That depends on physical distance. That is, first one is short transmission line up to 80 kilometers. Up to 80 kilometers comes under STL. What is STL? Short transmission line. Second one is medium transmission line, MTL, medium transmission line. It is up to from 80 to up to 160 kilometer comes under medium transmission line. Third one is long transmission line. Long transmission line is greater than 160 kilometer comes under long transmission line. Up to 80 kilometers short transmission line. 80 to 160 kilometers medium transmission line. Greater than 160 kilometers long transmission line. All these transmission lines are operating at constant frequency or variable frequency. Constant frequency, which is 50 Hertz. What is the frequency? 50 Hertz. If frequency changes, if this frequency changes, definitely the length also changes. That is the reason why this distance is applicable only for 50 Hertz. This is physical length, or actual length, but this is wavelength. Wavelength is very long, but transmission line physically not long, this much length. That is the reason why transmission lines are classified based on physical length. Up to 80 kilometers is short line, 80 to 160 is medium line, greater than 160 kilometer is long line. That valid is only for 50 Hertz frequency. Which frequency? 50 Hertz. Now, it is bus bar. This is alternator connected to bus bar, connected to transmission line. Already explained this diagram. Transmission line will have how many elements? 3 elements, R, L, C, and then it is load. Load side voltage is VR, current is IR. Source side voltage Vs, current Is. Any equipment is connected to bus bar or transmission line is connected to bus bar with the help of circuit breaker and relay. We know that circuit breaker acts as a switch, is the same function of switch. Listen, when switch is closed or circuit breaker is closed, short transmission lines and medium transmission line, when switch is closed or circuit breaker is closed, short transmission line or medium transmission line is taking less time to charge the line or more time to charge the line? Less time to charge the line. Short transmission line or medium transmission line is take less time to charge the line because of shorter distance compared to long transmission line. Shorter distance or long distance? Shorter distance compared to long transmission line. Short transmission line, see, when switch is closed, wave is traveling from sending end to receiving end. Therefore, the transmission line is getting charging very fastly, reason, or it takes less time, reason, because of short distance compared to long transmission line. Next, when switch is closed or circuit breaker is closed, long transmission line will take more time to charge the line because of long length. Therefore, long transmission line will take more time or less time? More time because of longer distance. Tell me, whenever it is taking less time, all you people are understand my concept with less time. Therefore, your steady state or transient state? Steady state. Less time means represented by steady state behavior, whereas longer time means represented by transient behavior. You people are taking more time to understand my concept. There definitely it is transient behavior. Very less time you are understanding steady state behavior. For steady state behavior, elements are represented in lumped manner. For transient behavior, elements are represented in distributed manner. For lumped elements, we have to apply KCL and KVL. For distributed elements, we have to apply mathematical modeling. Right? This is the simple points we understand from this diagram. Very simple. Short line, medium line, switch is closed, it takes less time to charge the line because of short distance. Automatically it is represented by steady state. Steady state elements are represented lumped manner. What is lumped manner? R, L, C, separated, all three are. Analysis by using KCL and KVL. Long transmission line, switch is closed, it takes more time or less time? More time. Therefore, definitely it is longer, more time means transient behavior. We are using mathematical modeling. Now, short transmission line is having 3 elements R, L, C. But because of shorter distance, capacitance will form parallel. As it is forming parallel, net capacitance adding. Therefore, capacitance is C plus C plus C plus C. It becomes NC. C1 plus C2 plus C3 plus C4, net capacitance adding. As distance of the short transmission line is less compared to medium and long line, this capacitance also approximated to 0 for analysis. Distance less, capacitance formation also less. Coming to medium transmission line, distance is up to 160 kilometers, therefore all elements are considered, that is RLC. Next, long transmission line also all elements are present, that is R, L and C. Long transmission line also all elements are present, that is R, L and C. C, short transmission line distance is up to 80 kilometers. Medium transmission line distance is up to 80 to 160 kilometers. Long transmission line distance is more than 160 kilometers. In short transmission line, capacitance is approximately 0. In medium and long line, capacitance also exists. Next, short transmission line is represented by, it takes less time or more time? Less time. Therefore, it is represented by steady state behavior, transient behavior, steady state. Medium line also distance less compared to long line. Therefore, it is also represented by steady state. Whereas long transmission line is taking more distance, taking more time, represented by transient behavior. Reason it takes more time to charge the line. Transient behavior. Whenever it is steady state element, we are using lumped representation. What is the meaning of lumped representation? R, L, C, physically separated. Whenever all these three are physically separated, we are applying KCL and KVL to analyze the network. Similarly, steady state means lumped elements representation. What do you have to apply here? KCL and KVL. For long transmission line transient behavior, for that which representation? Distributed representation. We have to use mathematical modeling. What modeling? Mathematical modeling. Right? This is the analysis of short line, medium line, long line. For short and medium lines, we can apply KCL, KVL, but long line we have to apply mathematics. Reason KCL, KVL fails for distributed parameters. Right? Next, it is one table. Another table is short line, medium line, long transmission line. Resistance depends on area. Resistance depends on area. Long transmission line, area of cross section of conductor is more. As area more, we know that area and resistance both are inversely proportional. Okay, first we will see the area for better understanding. Area of cross section of conductor, long transmission line is more. Short transmission line, small. Area of cross section of conductor, medium transmission line, medium. What about resistance? Area less means resistance becomes more because both are inversely proportional. Area more means resistance become less. Here medium size of area of conductor. This is the resistance. Next, area, resistance. Next, efficiency, percentage efficiency. Now only we discuss percentage efficiency is inversely proportional resistance or directly proportional resistance. Inversely proportional resistance. See, resistance more means efficiency become less. Resistance less means efficiency become more. Resistance medium means efficiency also medium. That's why it is 95%. It is 98%. Medium means more than 95, less than 98. That is the reason why I told beginning transmission line efficiency is 95 to 98%. Reason, different size of conductors are there. Short transmission line, less area of cross section. Long transmission line, more area of cross section. Medium line is medium, right? This is efficiency. Next, coming to length. Length of the transmission line is more in long line, 160 kilometers greater than 160 kilometers. It is 80 kilometers. It is 80 to 160 kilometers. The length of the transmission line more, definitely the capacitance formation also more. Therefore, capacitance formation is more in long line. Length is less, definitely formation of capacitance less. Length is medium, capacitance also medium. We know that when capacitance is more, change of voltage at the receiving end from no load to full load also more. Therefore, regulation also more. Regulation of which line is more? Long line is more. We know that change of voltage from due to capacitance, the change of voltage at the receiving end voltage is very high. As capacitance less in short transmission line, definitely the voltage at the receiving end also less, therefore change in voltage also less, hence percentage regulation is less in short transmission line. Medium transmission line is there, as it is having medium value, regulation also assumed as medium value. Therefore, the changes voltage at the receiving end in short transmission line is plus or minus 6% is the practical values. The change of voltage at the receiving end for long transmission line is plus or minus 12%. The change of voltage of the medium transmission line is plus or minus 10%. From this analysis, we understand very clearly efficiency of short transmission line is 95%, efficiency of long transmission line is 98%. I think there is no much difference between 95 to 98%. Therefore, efficiency is not creating major problem, but which is creating problem? Regulation. Regulation of short transmission line is 6%, regulation of long transmission is 12%. Which is having more change of voltage at the receiving end? Long transmission line. Therefore, performance of short transmission is always better compared to any other line in the transmission system. Reason, change of voltage at the receiving end also less. Unfortunately, short transmission line performance is better compared to long line. It is very nice, but practically power is transmitted by long lines or short line? Long line, but long transmission line regulation is less. More compared to short line. Therefore, the performance of long line is poor than short line. Therefore, we have to improve the performance of long line. That's why syllabus is extended. Right? Therefore, see, point is power is transferring maximum by long lines when compared to short lines. Short transmission line regulation less. Long transmission line regulation more. Therefore, the performance of long line is worse than short line. Anyhow, we are transferring power in long line. That is the reason why we have to improve the performance of long lines. That's why power system syllabus is extended. So, this is the analysis of short line, medium line and long line. Beginning also explained. Transmission line performance can be considered by efficiency and regulation. But efficiency is not creating problem, regulation is creating problem. That is the reason why mainly performance of lines is represented based on regulation. The line which is having low regulation is best, which is having more is worst. Therefore, long line performance poor. But anyhow, we are transferring power in long lines. Hence, we have to improve the performance of long lines. That we will discuss in power system stability after 1 or 2 hours. The topic will start. At that time, I will explain very clearly to you all these points. Right? Now, we will start the analysis. Please concentrate right now. Alternator is connected to transmission. Transmission is having how many elements? 3 elements. R, L, C. R, L, C. All these 3 are lumped representation or distributed representation? Lumped representation, because for easy analysis. R and L is series element, C is shunt element. We know that alternator voltage is E, angle delta. We will have 2 fluxes, one is stator flux, other is rotor flux. Angle between these 2 is delta. Sending end voltage Vs, angle delta. Current Is. Receiving end voltage VR, angle 0. Current IR. Current IR. Transmission line right now represented by RLC model. Transmission line right now represented by RLC model. Whenever we are representing transmission line by RLC model, we have to apply 2 concepts. One is KVL application, other one is KCL application. One is KVL application, other is KCL application. In India, we do not have one line. In India, we have infinite lines. As India, we have infinite lines, definitely we have to apply infinite KVL, infinite KCL equations. Therefore, number of network equations increases if you are performing transmission line by using KVL and KCL. As number of network equations increases, definitely complexity also increases. In order to reduce complexity, to solve transmission line performance, always transmission line is represented by ABCD parameters. Which parameters? ABCD parameters. Now, sending end voltage we know Vs, current is Is, alternate voltage E, angle delta, receiving end voltage VR, angle is 0, already explained about these angles, current at the receiving end also IR. Transmission line can be represented by two models. What is the model number 1? RLC model. What is the model number 2? ABCD parameters. Tell me, it is sending end values or receiving end values? Sending end values. Sending end values are unknown values or known values? Unknown values. Whereas receiving end values are known values. Receiving end values are known values. Why receiving end values are called as known values is, receiving end values are the load side, means our side. Assumption Hyderabad city is there. Hyderabad city is the one of the receiving end. By knowing the demand of Hyderabad city, we can generate power in the power plant. Sending end is power plant side, load side is city side, that is Hyderabad side. By knowing Hyderabad city power demand, we can generate the power at the source end. Without knowing demand of Hyderabad city, how much power we can generate? We can't generate. That is the reason why always sending end is depends on receiving end parameters. That is the reason why receiving end parameters are known values, whereas sending end parameters are unknown values. In order to relate these two, we are representing unknown parameter, that is receiving end parameters, by using known parameters with the help of ABCD concepts. Now tell me, what are the sending end parameters? Vs, Is. What are the receiving end parameters? VR, IR. Sending end parameters are represented in terms of receiving end parameters by using ABCD parameters. A, B, C, D. Sending end parameters are represented in terms of receiving end by using ABCD parameters. Now, we know matrix operation, row wise and column wise. What is Vs? Vs equal to AVR plus BIR. Next, Is equal to CVR plus DIR. Already these equations you studied in network analysis. These equations you studied in network analysis, right? See, simply I am explaining. Transmission line is represented by two models. One is RLC model, other is ABCD parameters. If you are using RLC model, number of network equations increases. As number of lines increases, equations also increases. In order to solve that equation, it takes more time. Disadvantage, time consuming process. If you are considering ABCD parameters, it takes less time. Why? Because simply sending end values are unknown values, depends on receiving end. That unknown values is represented in terms of known values by using ABCD parameters. By using ABCD parameters. Therefore, ABCD parameters are reducing time to solve the network transmission line parameters, whereas RLC models are taking more time to solve RLC parameters, that means transmission line parameters. And it is very clear, transmission lines are represented always by using RLC model, but ABCD parameters instead of RLC model. Now, I am going to explain very important point right now. Here is, already we understand, sending end values are represented by receiving end values by using ABCD parameters. That the equation is also clear. Next, every component of power system is connected to bus bar with the help of circuit breaker and relay. Every component of power system is connected to bus bar with the help of circuit breaker and relay. See, when circuit breaker is open means the line is not connected to bus bar. How much current is flowing through inductor? 0. How much current is flowing through inductor? 0. Therefore, inductor acts as a open circuit. Inductor acts as a open circuit. When switch is closed or circuit breaker is closed, okay, first, when circuit breaker is open, current flow in the inductor is 0, it acts as a open circuit. Voltage across capacitor also 0, it acts as a short circuit. We know voltage 0 means short circuit, current 0 means open circuit. Even though circuit breaker is closed, Inductor does not allow sudden change of current, still the current flow in the inductor is 0. Capacitor does not allow sudden change of voltage, still the voltage across capacitor also 0. Therefore, inductor acts as a current 0 means open circuit or short circuit? Open circuit. Voltage 0 means short circuit. Now tell me, when even though circuit breaker is closed, initially inductor acts as a open circuit, capacitor acts as a short circuit. Now tell me, transmission line is having combination of two effects. One is open circuit effect, other is short circuit effect. Therefore, we have to include both the effects at the time of calculations. I hope, are you getting? Right? Now only we discuss transmission line will have receiving end parameters VR, IR, sending end parameters VS, IS. Both are related by using which parameters? ABCD parameters. Or this is receiving end. This is receiving end. Now, sending end side is load side or source side? Source side. VS, IS. Receiving end is load side. VR, IR. How these two are related? By using ABCD parameters. Sending end is source side VS, IS. Receiving end load side VR, IR. How both are connected? By using ABCD parameters. In order to calculate the units of A, B, C, D, we have to apply open circuit effect as well as short circuit effect. Reason, open circuit effect as well as short circuit effect. Reason, inductor initially does not allow sudden change of current, capacitor does not allow sudden change of voltage. That is the reason why first we have to apply open circuit, then short circuit to calculate ABCD parameters.